Look closely at these two. They are starting from almost exactly the same place, so close that no eye, no instrument could tell them apart. Watch what happens. In just a few seconds, they will have nothing in common, spinning off into completely separate fates. And nobody, no matter how clever, could have predicted which way either one would go. Here is the strange and beautiful part. That is not a failure of science. It is a law of nature. You have felt this law your whole life without knowing its name. It is why the weather forecast is rock solid for tomorrow, wobbly by next week, and simply useless past about 10 days, no matter how enormous the supercomputer crunching the numbers. We did not just get sloppy at forecasting and bump into a temporary wall. We ran headfirst into something far deeper. The wall is not in our machines. It is built into the fabric of reality itself. In the winter of 1961, a quiet meteorologist named Edward Lorenz was running a stripped-down model of the weather on one of the first computers. One morning, to save time, he restarted a simulation from the middle instead of the beginning, carefully typing in a number he had copied off a printout, 0.506. What he did not know was that the computer had secretly been carrying more digits, 0.506127. A difference of 1 part in 1,000. He went to get a cup of coffee. When he came back, the weather the machine had produced was not slightly different. It was unrecognizable. That microscopic error should have made a microscopic change. Instead, it grew and grew and grew, doubling, then doubling again, until within simulated weeks the two forecasts had absolutely nothing to do with each other. Lorenz had stumbled straight into the beating heart of chaos, what we now call sensitive dependence on initial conditions. In an ordinary system, small causes make small effects. In a chaotic one, the tiniest difference refuses to stay tiny. It explodes. Lorenz reached for an image, and it stuck so hard it named the whole idea. If the atmosphere really is this sensitive, he said, then the flap of a butterfly's wings in Brazil could, weeks later, be the deciding factor between clear skies and a tornado tearing through Texas. Not because the butterfly is powerful, it is absurdly weak, but because the air is listening to absolutely everything at once and patiently amplifying the faintest whisper into a world-shaking roar. Now here is what makes chaos so genuinely unsettling, so hard to accept. There is no randomness anywhere in Lorenz's equations. None. Zero. They are perfectly exact, feed in the same numbers, and you get back the same answer every single time forever. A chaotic system is completely, rigidly determined by its own rules, and yet it is fundamentally, permanently unpredictable. How on earth can something be both of those things at once? To find the answer, you have to stop staring at the numbers and start watching the shape they trace out in space. Take Lorenz's system and plot its path, where it is at every instant, and something impossible slowly appears. The path never once repeats itself. It never settles down to a stop. It never, ever crosses over its own trail. And yet it also never escapes. It loops and wins forever around two great hollow wings, weaving a figure of infinite, impossibly delicate detail. Mathematicians gave this ghostly object a perfect name. They called it a strange attractor. Sit with what that actually means, because it is the whole secret. The system is chaotic. You can never, ever say precisely where it will be next. But it is also deeply ordered, because it will always, without exception, be somewhere on this one exquisite shape. Chaos, it turns out, is not the absence of order at all. It is a stranger, deeper kind of order, a system that is perfectly free, and yet trapped inside perfectly rigid walls, utterly unpredictable in the small, utterly beautiful in the large. And you do not need a computer or a weather model to shake hands with chaos. Take two rigid rods and hinge them together at the middle, a double pendulum. The rules governing it are nothing but gravity and geometry, simple enough to scribble on a napkin. But lift it up and let it go, and its motion is pure, unfiltered chaos. Whipping, tumbling, folding back on itself, never once repeating. Now start two of them from what looks to your eye like the exact same pose, and release them together. Within a few short seconds, they are dancing to completely different music. So is prediction just hopeless, then? Not quite, and this is the subtle, crucial point. Chaos does not make the future unknowable all at once. Instead, it puts a horizon on knowledge. You can see a little way ahead perfectly clearly, and then the fog of amplified error comes rolling in and swallows everything. For the weather, that horizon sits at roughly 10 days. Push a single hour past it, and every forecast becomes a coin flip. And no computer ever built, however impossibly vast, can shove that horizon further out. And once you have learned to recognize the signature of chaos, you begin to see it absolutely everywhere. In the lazy swirl of smoke rising off a candle flame, in the healthy beat of your own heart, in the boom and sudden crash of animal populations, in the orbits of the planets over millions of patient years, in a dripping faucet that stubbornly refuses to keep a steady rhythm. Chaos is not some rare and exotic accident. It is the quiet default behavior of very nearly everything in the universe that moves. And here is the final twist, the one almost nobody sees coming. Chaos is not the villain of this story. A heartbeat that is too regular, too perfectly metronomic, is the sign of a heart that is dying. A truly healthy heart is subtly, restlessly chaotic, always poised to respond. A climate incapable of chaos would be dead, frozen, uniform. Evolution itself needs the unpredictability in order to explore and to invent. The entire dazzling richness of the living world is built directly on top of the very wildness we are taught, from childhood to fear. Which carries us at last to the deepest idea buried in all of this. For 3 long centuries, science quietly assumed that if you only knew the rules exactly, and the starting point exactly, you could in principle predict everything forever, out to the end of time. Chaos gently, permanently shattered that dream. A system can obey perfect laws with perfect precision and still be genuinely unknowable. Not because we are missing some crucial piece of information, but because reality itself simply does not come stamped with infinite decimal places. Determinism and predictability, we finally learned, are not the same thing at all. And right between rigid, frozen order, a crystal, a ticking clock, and pure, formless randomness, static white noise, there lies a narrow, astonishingly fertile band, the edge of chaos. It is exactly there that snowflakes take their shape, that hearts keep their time, that minds somehow manage to think, that life itself first took hold and never let go. Too much order and nothing interesting ever happens. Too much chaos and nothing interesting ever lasts. Everything that matters, everything alive, lives balanced right on that razor's border. So the butterfly effect was never really about butterflies, and it was never really the grim news that the universe is cruel or broken or random. It was a genuine discovery that simple, exact, unbreakable rules can conjure up endless, unrepeatable, unpredictable beauty. Order and chaos, it turns out, were never enemies at all. They are partners in a single dance, and the strange attractor is the shape that dance traces on the dark. This is Chaos Canvas, powered by Incant, where we take the hidden mathematics of nature and render it into something you can actually see. If a chaotic system quietly tracing out its own secret attractor made you stop and look twice, then subscribe, and stay a while because there is always more order hiding in the noise.